In this tutorial, I'm going to talk about how to build a AI assistant agent for natural language to SQL, query generation and execution on live databases. So I'm Cainã. I'm just finishing my postdoctoral position at W Madison, Department of the Nelson Institute of Environmental Science, where I have developed this product, like end-to-end, connecting to Slack. So the users, domain scientists, stakeholders, they can tag the bot in the Slack. That's the main communication channel for the lab. And then it's going to start a thread, just like a section to ChatGPT. They can like interact with the database, ask questions, follow-up questions. It has memory, it has a bunch of functionalities, and I'm going to teach how to do it by using a toy dataset from Kaggle. So the agenda for today, for this tutorial, is I'm first going to introduce about what is natural language to SQL, what is important, and the main components of it. And then I'm going to highlight and explain some famous frameworks to do it. We're going to deep dive in LangGraph, but I'm also going to show other possibilities, including no-code, for example, LangChain, also Vanna AI, Llama Index and LangGraph. Just out of curiosity, how many of you are familiar with LangChain and LangGraph? Can you hands raise? Okay. Llama Index? Okay. Vanna AI, have you ever heard about Vanna AI? Okay. And LangChain? Okay, good. So, yeah, like I told you, I'm going to just like highlight the possibilities using these different frameworks, but I'm going to deep dive on the LangGraph one. So, I'm going to stop here for a while so you can access this link or scan the QR code. Then it's going to take you to a Google Docs with the code of the repository. I'm also providing for you some OpenAI key, so you can use it for this tutorial. And the credentials for the database. So I have a database hosted on AWS, so can I proceed? Okay. Yeah, sure. Okay, is someone is missing? Okay. Okay. So what should you expect from this talk? Basically, is get familiar with natural language to SQL, the requirements, what it is, discuss some trade-offs on the different approaches to implement it, and also get familiar with the most famous frameworks to do it, and some hands-on experience as well. And I'm also going to provide the code, quite similar to the one I have used, is currently used in production. But again, for this toy dataset from Kaggle, but I'm not going to deep dive, like spend a lot of time, because 1 hour and 5 minutes not enough to explain everything, so you feel free to explore it later as needed. And also, you can also reach out to me if needed. So why text-to-SQL? So I have some main advantages of building a product like this. The main one, I would say, is accessibility. So the main scientists, stakeholders, non-technical people who doesn't know how to code in SQL, they can be able to access the database. Constantly, we're going to remove some burden of the data engineers responsible for actively creating these queries. Therefore, they can work on more complex, high-value tasks. You also can standardize some safety checks and so on, and it helps standardizing. About limitations, One of it is accuracy. So we really want, depending on the case, most cases, but at some cases, like crucial to have, we need to be sure the query is outputting the correct value, right? So in order to do it, we need to work quite a bit with context, providing as much context as possible in the smarter way. And you also need validation, and ideally some human in the loop, at least for the first phase of the production. So it's quite important. So it's quite context dependent, this kind of product. So I'm going to show how to do it. So if you're going to talk about the components, I would say we have like 3 main components. Of course, we have the user query, like the natural language, like plain English question about the database. And then you need a large language model who has knowledge of SQL. So it knows the SQL syntax across different SQL engines, for example, Postgres, MySQL, and so on. The current state-of-the-art models, they have this knowledge, so that's be good if you're going to use a host model. If you're going to use a local model, like perhaps it's better to fine-tune it. And other than that, we need the context for the large language model. So the large language model should be able to know what the tables they can access, how they relate to the other, the relation between tables, columns, how do they make the join. So they don't need to have information about the data itself, like the cell values you see in the table, but they need to know the data schema. So that's crucial for like working, having a good accuracy for this model. So ideally, it's good to have primary keys, foreign keys established. We can provide context using data types, some comments. Most of the database they can have some comments, so we can provide some specific domain knowledge about what is this table about, what is this column about, like the most common values and so on, the most common like purpose of this column and so on. So it helps a lot, like I have seen it in my implementation. That's the data schema, that's crucial. And another thing that I can provide is examples, like to provide a few short examples, for example. So I have like pairs of questions and expect answers, expect generated code from SQL. Additionally, if you want, you can provide some domain context, but just like I said, I would do it like using the comments of the database directly if possible. So how do you provide this data schema, the context? So I have different ways to do it. You can just dump everything in the system prompt. So like you dump the data schema, the system prompt, of course, going to increase the amount of tokens, the input tokens, but the model is going to learn like right off the bat the whole schema and going to be able to provide probably accurate responses in case like we don't have like a very huge database. That's one way to do it. Another way to do it is using RAG. So instead of providing all data schema and examples at once every time, we can. How many of you are familiar with RAG? Retrieval augmented generation. Okay, so just a quick explanation for those that are not familiar with it. RAG stands for retrieval augmented generation. So it's a way to add more context for the large language model. So the large language model is not trained if hopefully it's not trained with a database for the company. So one way to add context with it, like we just chunkanize all the data examples, the table, and provide as an embedding, like we create a vector database, and then we perform like we calculate the similarity between the user questions and the examples that we have in this vector database, and let's say we retrieve like the 10 most similar examples. So if the user is asking, for example, for computing a product, like so we have a table called products, the similarity is going to find this table and provide as additional context to the large model. So it's good because when you have like a really large database, it becomes really expensive to dump everything in the system prompt at once. So you don't want it many times. So another way is to provide a hybrid approach. So you need to provide data schema. Ideally, you need to provide some examples as well. So we can just like what I have done for my user case, I have like manually filter, I have like a config file that I select the target tables and columns. So if the column, for example, the table doesn't have any comment in the database, it's going to ignore. It's only going to populate the target tables and columns that I want. So I'm dumping everything in the system prompt of the target tables and columns that I want the user to be able to ask questions. And then for the examples, I have like a bunch of examples, continuously increasing the amount of examples. For the examples, I'm using the reg. So the user asks a question, is going to find the most similar previous asked questions like that that has a correct answer. It's going to provide as an additional context to the model. And we have different ways to implement it. I have different frameworks. Specifically, I have like no/low code solutions. For example, LangChain. I'm going to show how to use it quite quickly. We have some templates available already. And of course, I have a LangChain, LangGraph. It's the one that I'm most familiar with. But I have also searched for how to implement it using Llama Index and Vanna AI. Vanna AI is a very good framework. When I started this product, I didn't know it, but it provides like really good way. It's RAG-based, 100% RAG-based, and then you can train the model. They say train, but when I say train, it's like adding examples to the vector database. Then you train the model, add examples for the data schema and for the pairs of questions and expect SQL code. It's quite easy to use. I'm going to show it as well. So. And you can also take different approaches when implementing it. One classical approach that I have used is using a sequential approach. So we just have just like a graph, like using LangGraph, for example, just like a graph, you have like the model, the system is going to receive the questions of the user. Then you're going to write a query, like the large language model is going to write a query for it using the knowledge of the data schema and examples. Then we can have some guardrails, that's not written here, but we can have some safe checks, and then you can execute the query. And then like we analyze, interpret the query, and provide the response to the user. We have way more control of the application when you do that. On the other hand, you can use like a classic and famous agentic approach using React, like reason and act about it. So basically, we provide all this functionality as functions, as tools, and the agent has tools, for example, for listing the tables available in the database. They can have a tool. It has a tool to query the database, to analyze the response, and so on. So it keeps like reasoning about the output of the tools until we come to an answer. It's actually easier to implement, I would say. It's more flexible, but you don't have a lot of control about the output. And at least in my opinion, that's fully opinion-based. For this kind of process, I highly prefer a sequential approach because we have like a clear, like the steps are clearly defined. So you want to write the query, you want to validate the query, run some safe checks, and execute the query, interpret the query, and so on. So it's kind streamlined to do it. It's easier to debug as well. So the approach I have taken is this one. So using LangGraph, so basically the user asks a question, and I have a main router just to define if it's just a small talk or like the user is actually asking a question about the database. If it's a small talk, it's going to reply politely and have some, in this case, in the right panel, I have a React approach. So I have like options to explain query in details in case previously they have asked a question about like generate code. That's more for didactic reasons because we have some domain scientists who want to learn SQL, and that's a really good way to explain it using the real data set that they want to work with. And then like they can apply, okay, I have this query and this, I have this question, this example, please log it to the vector database to provide as additional example later. If the question is about the database, So I start the process. So first, grab the data schema and so on, and try to generate the questions. If for any reason it's not able to generate it, it ends and replies to the user. For example, if I was working the database with data from Brazil and the US. So if they ask question about Japan, we don't have data about Japan. So in this case, it's going to say, okay, we cannot answer this question. Like we have like in the system prompt, instruction to not guess if they don't have it explicitly. So then we validate it. We have like a syntax validation and a safety validation to avoid like drop statements, super data, and so on. In case it passes, it goes to the human in the loop information, so it shows the code for the user, a small explanation, and has a button to explain, okay, do you want to run it, yes or no? So that's the stage we are right now, and they can execute it if needed. But so far, like we still relying on the engineers for doing that to make sure it's good. But I think it's quite interesting, this approach, because stakeholders like it. Since I was working research for the final numbers, the engineers, they take this code, like copy and paste the question for the domain scientist, but they can validate like if it's actually correct. And so far it's working quite good. Okay, so let's have some hands-on. So I have shared with you the repository, this one. Everything has access to it, the link, okay. So yeah, this disclaimer, this project was originally prepared for SciPy, but I'm not going to talk in details about the LangGraph implementation because there was 4 hours, so instead I'm going to provide familiarity with the whole process. Then you can use, what you need to use here is like an ID, ideally Docker if you want to run locally, but I have also the credentials so I can connect it directly to the database. And if you want, an IDE for SQL as well. So I use the Beaver, but you can use anyone. So let's take this. Here. Let me change to PyData building. So, by the way, I'm going to work with the OList e-commerce datasets, like datasets from Kaggle. It's in the README. I'm not going to focus on the specificities of the database itself, but it has 2 schemas. So it has a schema about e-commerce. So I'll have some tables here. Wait. Okay, it's taking a while. I'm not sure if it has many connections. So I'm going to use the exactly same database. I'm going to use the local host just to speed up the process here. But it should work on the AWS as well. Let me know if not, it's not working. So let me do it easier. So I have like tables about customers, allocation, other items, other payments, and so on. I also have another schema called marketing. With funnel tables, so qualify leads in closed deals. So if you go to the repository, there is a folder called artifacts. In this folder, we have the the schema for both databases. So I have the information about both schemas. So that's the e-commerce one. So we have all primary keys, foreign keys, and so on. So it's already primary keys, foreign keys is settled, comment is settled, is everything good to use. And here we have the marketing funnel by O-list. So let me start with like the easiest one, like NHN. So under the docs, I have a document called nhn.md. So I can try to follow these instructions with me. So first thing you need to do is to install nhn. So in case I have already installed, right? How if you do you have Docker installed? Okay, just some. Yeah. So the ones who don't have Docker, I think just like follow along with me right now. Then I can install it later. Okay. It's only for NHN, and if you want to run locally the Postgre database. Okay. So basically, we should run this command here for the ones who have Docker installed. In this case, I already have it, so it's running already. If I go to the Docker here, I'm going to see NHN is running. It's running this port here, like localhost 5678. So let me exclude this one. The first time that you open it, it's going to ask for email and like username and login. So it's like the admin privilege. So like you set up for the first time the username and login. Then you can add the credentials. You're going to need to add the credentials. I can go to this arrow here and create a credential. In my case, I have already created. Let's see. But I can create it again, just in case you want it. So let's try it. So you need the credential for the OpenAI. So because in this case, you can use any large language model. So here I'm going to use OpenAI. You can copy and paste the token that I have shared with you. It has a limit of like dollars on it, so don't use it like too much, otherwise I cannot. And also Postgres, I look for Postgres. And here in the host, you can provide the host from here. I haven't tried, let's try, let's see if it's working.
So yeah, sorry for interruption, but this is tutorial. So usually for sessions you have videos that, yeah, there's a website for Q&A, but this one is tutorial. So feel free to, when you're following the speaker, if you have any questions come up and not catching up properly, or sorry, can you show me, or if you don't understand, just feel free to show your hands up. It's okay with you?
For sure.
Yeah,
please do that.
I just wanted to let you know that is, yeah.
Thank you, thank you. So here we need to connect to the database. So let's try to connect to the AWS. Let's see if it's working, because like I have like multiple people connected right now. So host is the one that I shared in the Google Docs. Database name is olist_ecommerce. Then user and password is Postgres. Okay, it's working. Okay, it worked. So far is anyone following with Docker here, this part, or just like following along by? Okay. Okay, yeah, that's true. Okay, that's true. And is someone else trying to follow this Docker part? Okay. If you want me to wait for a little bit, just like let me know, okay? Or like I ought to go back to the explanation, so. So basically right now, I'm going to create a workflow, like from scratch, right? So in this year, we work like it's like interactive, like a low code, no code like approach. So I can just start, and LangChain has it is specialized in automation, so it can automate a lot of things in LangChain. It can also provide this kind of SQL assistant directly. So we can either do it like manually. We can, for example, let's just show how would it be like. We can have like a chat. So creating the chat, and then it create these. I don't need to set anything here. Just like let me close it, and then I can add a AI agent here, like AI agent. I'm not going to touch on it right now. So this is what we have that we can start work with it. So the AI agent, it has like a chat model that we need to connect to some LLM, OpenAI, Anthropic, DeepSeek, or Llama, whatever. It has some memory because every conversation, just like the ChatGPT UI, you can have a session that you start, and within the section, it has memory about the conversation that's going on. You can set it, it's optional. And then you have the tools. So in this case, you're going to take the React approach. So it's going to reason, act, observe, reason, act, observe, until we come to the answer. So we need tools for accessing, for listing the tables, for executing the query, and so on, right? But instead of doing it manually, on the docs, I'm sharing this link here. That's the markdown under the folder called docs. And then we go to it takes to the LangChain website with like predefined workflows. Those are the templates. So it has thousands of it, more than 5,000 templates. This is one using Postgres, just like what you want to do here. So we can just like use it for free and copy as a JSON, and then import the JSON file to LangChain. So in our repository, we have it under the artifact folder. We have this JSON file that I have downloaded from their website. And here I can go to these 3 dots, like import from file. And let me find. Then I upload the JSON file from that. And then here I have the whole workflow. So let's clean it a little bit and explain it. So here, if you click in this part here, we have the chat that you can talk to the large language model. Here we have the main node, the AI agent that you can specify the large language model, the tools, the memory, and so on. And also can provide a system message that's also predefined for us. So it says that I have access to tools, is a specialized agent responsible for creating SQL queries and so on. So I have defined a system prompt. It has access to the model. In this case, let's see here, it's using ChatGPT. We need to change it here because the OpenAI key I have provided only accepts 4.1 and 5, the mini nano versions. So we can change here for 4.1 mini, for example. Chat history, he's like running locally, but you can also store on the database, the Postgre database directly, so we can access the history later on. So let's do that. I just excluded it. I'm going to provide the Postgre chat memory, and I don't need to modify anything here. It's going to create a table called LangChain underscore chat underscore histories. Since we start interacting with it, we're going to be able to see it. Okay. Let me change it here. And here I have some errors. Let's see. Probably because it's coming from a template, but if it just try to execute it, let's say here select one. Anything here, it should be able to work. Let's see what happens. Oh yeah, because I need to create another credential here with the correct file. So because my credential I have set up for the local version. So. Okay, worked. So here's probably going to work as well. Okay, so now I can try to chat to see if it are happening. So let's try, like, say, hi. Here you can see the log. So it's quite fast. So basically, the chat went to the AI agent that went to the model. It also updates the memory. Actually, I first updated the model, called the model, and then I could update the memory again. So I see the steps here. Then let's say how many users do we have in our database? A very simple question. So it only requires one table to see it, but just to see it working. So here it's taking a lot of steps, like updating the memory constantly, and like calling the model, then it called the tool to list the tables, send back to the model, and execute the query, send the result to the model analyze it, update the memory, and provide the answer that it's over here. And anything we can like just replace the chat, but any kind of webhook, for example, for using connected to Slack, connected to a specific UI of your company, and so on. And then also provide the output for back to the UI over here. That's just one way to do it. Not going to focus on any chain here, it's not the goal. Just to say that we have some local no-code solutions. It's quite easy to implement, but you don't have a lot of control in case you want it. So we can control the system prompt here, we can provide some specific tools, but any kind of specialized guardrails or any kind of customized solutions is not going to be possible to work with it. And also, we have some concerns about scalability for many users and so on. So depending of the size of a company, of a lab, it might work quite well. So that's not what I have chosen. Usually, at least I and some friends use LangChain to provide some POC, some proofs of concept, just to show the stakeholders, oh, that's how it's going to work and so on. And then we can start like a more complex and reliable solution. Oh, yeah.
Why yours was working and mine wasn't working, or just
You're talking about this button here. Yeah, this button here is about making it to production. So, for example, right now we are in development phase. So the active is kind of moving to the production phase. So, for example, let's just try a Slack input here. Just simulate like input trigger. Set trigger general action event. Okay, and it's not going to work because I need to have a credential for Slack here, but we can see if you use actually using Slack here, it's going to provide a link to Slack for a dev, like so a dev phrase of it, and then you can like test it, interact, and so on. But then it's only going to be trigger when you trigger like clicking the button here, because like you're just developing. Once you change it to active, then it's going to provide another link. That's a production one. It's going to be listened all the time. So there's every time the user asks a question, it's like, so it's going to going back. So basically, it's a production-related feature. Does it answer your question? Okay, okay. Okay. Yeah, again, that's all specified in the README for LangChain. And the goal here was just to show one possible and the easiest feature, the way to implement it, I would say. Is it okay? You have any questions here before we move to other framework, not using Docker? That's a good question. So, for example, in this case, the specific case, you're asking about this in general. Okay. A different way to do it. Like in this case here is kind of doing it already because it's going first like showing the whole the tables available. Then like it says the first like response to the model, like we have all these tables available. So based on the user question, like just like reason about which table is necessary for you to get further information in order to understand the data schema and generate the query. So that's one way to do it, like based on tools, like list the available tables and not going, but this is the name of the table, schema name. And then a second round, we try to get all columns and so on.
Do we need to specify the name of the table? Because let's say you just want to, you have a question, but it should go on.
We don't specify the name of the tables. We can here only specify we have this. That's the output going to be provided for the model for the first trial. So basically, in this code here is retrieving the first response to the model, is listing all tables across all schemas. But you can filter here for specific schemas if you want. But it's, in this approach, it's always going to show all tables in a schema, but just listing the table, the name of the tables. Then the model needs to reason again to know which table they want to get details that they think the Jude is useful for generating the query. Okay. That's one way. Another way that I have done it, from not using tool, because I haven't used the React approach for solving this problem. So in my case, I have like a config file, because we have some specific tables, schemas that we want schemas and slash tables that we want to use. And then I have a logic where any columns that is not, we don't provide comments, because I have like a lot of legacy columns, a lot of legacy tables, and so on. So if you don't have comments in the column, it's not going to populate the system prompt. So the model is never going to know about them. So like we reduce tokens because we don't want to use to query these columns anyway. So. Yeah. Next, I'm going to talk about LangChain, Llama Index, and Vanna. So, any other question about this approach? Okay. Okay. Very useful for proof of concepts, I would say. here. So if you go to the repository, here I forgot to say, I use UV. So UV is like a Python package manager. It's really fast, just like Poetry. Like it has, it combines a lot of tools like pip, pyenv, and so on. Just like all in one tool, writing in Rust, quite fast. And it's easy to install the correct Python version, all dependencies, and so on. So I really recommend that README has instructions to install it. Is this like one command line? So if you see, actually not here, so let me show here. So it's one line to install UV from Mac on Linux, and from Linux, that's this other line here. And once it's installed, you can just go to repos and run UV sync. So it's going to create the environment, install the Python if it's not installed yet, and install all dependencies in a very fast manner. So, and also has a really intelligent cache. So since I have installed it already, so it's resolved. But you can try it. You're gonna see it's quite fast. I'm really like UV. So now it creates a VM file. So I have my virtual environment file here, and I can use it for running the notebooks. So the notebooks I'm going to talk right now, they are in the full notebooks and SQL agent demos. So you have like the LangChain, Llama Index, and Vanna AI. So let's try like Vanna first, before I can start the full real in LangChain. So I'm using Jupyter Notebook from inside my ID. You can just like use it the way you want. Just need to connect to the Python that we have installed here. So I have some comments here. So Vanna AI is like an open source library to create and execute SQL and code. It's specialized in SQL in this kind of application. So it was created to create SQL assistant. So it's 100% RAG-based. So the user asks a question and is going to search for the schema information that's in the vector store, any kind of documentation that's also in the vector store, and pairs of query and answers. So you can connect any kind of vector store, then you can connect any kind of large language model. It's going to generate the query and execute it. And then it's going to analyze and generate some plots using plotly. Then it asks for human confirmation. So if it's correct, it's going to train a model again with like this new example. I think it's pretty clever approach, but also like we have trade-offs, right? Anything that's too easy to implement, we lose control like of customization. So that's the main issue. So here I'm going to create like, I'm following the instructions, by the way. Okay, so if you click this link here, it's going to show a tutorial to do something quite similar to this notebook. Basically, you import the libraries, and you should instantiate this function as per documentation. Just choose any kind of LM and vector store that you want to use. So using ChromaDB because it's local, just for didactic purpose here. It's in memory. Then we instantiate it using the OpenAI. This here is only going to work if you have the .env file here. It's not by default in the repository because you should never upload this to the repository. Just exactly like the .env.example, we can just copy and paste this and replace the placeholder of the token that I have shared with you. Okay. Just right now, only this line is important here, the open API key. Once you do it, like this restarts the kernel. If you like coding with me, just restart the kernel to be able to recognize the environment variable. And then you connect to the database. Here I have it like it's running locally and also in the AWS. So let me keep it local here. Okay, let's so let's run it. It's connected. Once it's connected, like we can execute any kind of query in the database. So let's select this, like select a table itself, and then you can ask questions. So let's ask a specific question here. And this case is probably going to generate an error, as I expect, because this model hasn't been trained it doesn't have any information about my data set yet. So if you ask a question, it's going just to guess, it's going to hallucinate here. Like I select category from product, just like guessing the name of the columns and tables. So like 2 comments here. So far, you don't have information for the model to learn about it. But another comment that I don't like in this approach that in Vanna AI, because I think we cannot customize all the system prompts and the prompts they use. So I really like to add a simple comment that makes a huge difference. Like if you don't know, like if you don't have information in the database, don't guess. That's simple, but it's very effective. So far, apparently they don't have done it, because otherwise the model wouldn't hallucinate like this. So let's keep our effort. And then I just follow the instructions to provide the information based on pre-existing data set. So just like we use a common SQL query to grab this information, here just like filtering for these 2 schemas that I have. And then there is this special method here to generate kind of a plane to populate the vector store. So that's the original table. That's from SQL, just common SQL execution, nothing to do with Vanna AI here. But Vanna AI is using this to teach the model, to populate the vector store. So what I have done here is just like filtering the table schema for e-commerce and marketing. And then that's the plan of training it. Then I can train it. I can show the training data. So I have so far only the schema, but you can also provide examples. And then you can ask again the same question. Hopefully it's going to work right now. Okay. So it generates the SQL code, the response. It's generating the plot directly here. So basically that's the answer. Based on my knowledge about this data set is correct. But it's also simple. It's not like anything too complex to generate here. Basically, when you run this, the result of this model is like basically like a generate query, generate output in the figure. And the figure is a plot slide figure, so you can like customize it later and so on. Again, pretty convenient, but hard to customize if needed. So you also have like this option to create an app out of it. Then it provides a very convenient way to connect to Slack, to connect to UIs and so on. So let me ask the same question here. What was the question? Yeah. So something that I have realized is that even though the query is correct and the table output's correct as well, this graph is weird, it's off. Right? The cama mesa banho, that's like bed, table, and bath, is in, that's like order, right? 0 to 9. So it's not actually the actual count. So it's not these numbers here. So something's off here, but it's only off in the AI. I mean, in the app, not in the response from the notebook. Again, is it worth it to try it, spend time trying to debug internally in the library? I'm not sure. My approach would be like try a LangGraph approach. And then you can see here that's the for the one interested in it. So that's the way. Coding for the code side is pretty easy to implement as well. And you can like keep adding examples, keeping like training the model for the schema and so on. You can like remove trainings and so on. It might help the model. Any questions about this possible framework? Yeah. So what's the RAG part? What's actually interesting?
Yeah. Of course. I was asking about the RAG underpinning for Vanna AI. I wanted to understand where the chunking is happening and like, is it happening at the database level or the row level or something else? And how is it being retrieved for the questions that I'm asking?
Yeah, no, that's a very good question. So it's happening in this specific cell here. Basically, like this part, we create this plane. So this plane is kind of special object of this library. And it's actually training happening this part here. So when you say train, that's actually chunkinizing, populating the table. So before running this cell, we didn't have any file on this folder. Like we start without files here. And after running the cell, now I have like a chroma.sqlite file. And then that's already chunkinized. So I have like 12 chunks here. Okay. So it's using these here. So it's like set on the path. You can like configure the path. That's customizable list. Right. Okay. I'll have like 8. So just like talking about Llama Index and LangChain, they also provide abstract ways to do it. So I almost finished with the abstract ways. Then I'm going to show how we can explore later the more complex part with like real implementations, following all the best practices. Right now, just like overview of the libraries and using abstracted functions and classes and so on. So Llama Index and LangChain, they also provide abstractions, like high-level abstractions for querying the database. Llama Index basically has like 2 main classes here, like SQL database and this natural language SQL table querying engine. So you can just like load it. You just specify all the connection to your database. Since in my case it's not in the public schema, I need to specify the search path here. Okay, that's particular for the way I have built this database here. But then it's quite like easy. So just like provide an engine to SQL database, then you have like access to all these tables. That's all tables providing the e-commerce and marketing schema. You provide any kind of large language model. So we here like using OpenAI. And then we start this query engine. So we specify what is the database, the object, Llama Index object. a large language model. And here, at least, if you want to customize our prompts, we can customize it, as long as you provide the keywords for like the SQL, for example, the context, and so on. So I can access the documentation to see it. But that's I like about it. So we can customize the prompt the way we want here. So that's good. And then you can just query any kind of like question. So if you query a question, it's going to provide a response, a result object, and this result is like actually a response object that has metadata, including the query, generates query, the metadata of the output result, and also the final answer. So the final answer is taking into consideration the both original question, the output, and then analyzing the response, please answer to the user. So quite simple. Then you can use LangGraph. You can use any kind of like orchestrator to build the whole product that you want, like include memory, long-term memory, short-term memory, sessions, and guardrails, and so on. Yeah. Sorry. And finally, talking about the abstractions of LangChain, it also provides some abstractions. So in this case, using a React approach, just like LangChain. So like we have the common logic here, like we initialize the SQL database, we initialize the large language models, we retrieve the tools. Tools are nothing more than functions, in this case like Python functions, but we already have defined Python functions because that's quite common, so they have implemented already. And then you can create this React agent and start querying it. So in a short time, it's quite easy to implement as well. But again, that's only customization that it's, but you can customize more here, I would say. So basically, like we instantiate the engine, the SQL, then you can just like Vanna and so on, you can run the database, just like Llama Index, get access to the use tables, you can run queries, initialize a large language model, and you get access to the tools. Of course, you can provide customized tools as well. You can provide any tools that you want. So in this case, they have like these tools here, like the query SQL database tool, that to get information about the database, lists the database, and checker. So that's an additional tool compared to the LangChain template we saw. They didn't check the query. So here we have like a checker, that's good. Then you can provide the system prompt. So I'm also taking this from the official documentation, and you initialize the React agent. And then you can, like, here I'm streaming, but I can just invoke and do it all at once. And then you can see, just like we saw in the LangChain, it's exactly the same approach. By the way, LangChain uses LangChain under the hood. So like you have the human message, so they recognize it, reason that it needs to use a tool call. In this case, it's using the to list which tables are available. Then it provides the output to the large language model that is going to reason again, to observe and reason again. Then like, now it knows it needs to use another function, like to get the schema about these specific tables they judge. Then it's necessary. Then they provide it, and then they provide the answer here, and then reply to the user. So let's try to run it here. So it's running all steps sequentially. So, it's quite convenient, but quite difficult to debug in case anything's wrong. So it's way easier to debug like streamlined pipelines using LangGraph. So here, let me see if it's working. LangSmith. Okay, it wasn't working here. Okay. So another good thing about LangChain, like that I like it, is you can use LangSmith. That's a observability tool that's quite easy to manage, to track costs, debugging, to see all the pipeline, how the amount of tokens used in the input, in the output as well. All you need to do is provide these the variables here. Just like you log into account, LangSmith account. We have a free tier, but in this case, it's a paid service of like the LangChain enterprise. But it just provide once in the as environmental variable. Then you can every time that you run a LangChain call, prompt, LangGraph, and so on, it tracks the amount of tokens, the latency. We can like visualize the steps, and so on. It's quite good for debugging later on. Okay, so just confirm what is the last time that we have? Or what is it in? Yeah. How many time do we have left? 20. Okay. Okay. So, any questions about this overall, like, easier, like, frameworks approach to do it? Okay. Thank you.
I have a couple of questions.
Yeah, please.
Thanks for the talk. I mean, yesterday we had this haystack, I guess, the talk, and also the question was, what's the difference between haystack, and which one would you rather go? I mean, one problem with LangChain is that it's not well documented, or it gets super complicated when your project grows. I wanted to know what your experience with that one. And the second question I had was, I guess you are building these agents as a part of only for querying database. Let's say you have a problem for forecasting something, and then you ask a forecasting problem, and it needs to call the agent to acquire the data and to pass it to the main agent, basically. Did you have experience with this kind of multi-agent, that you have one specific agent for the database query, and then other agents for basically doing the forecasting or analysis task? And how did you basically do communication between them? Which frameworks did you use? Yeah, thanks.
Yeah, good question. So about the haystack framework, honestly, I don't have experience with it directly, so I cannot talk much about it. I really like the presentation, by the way. So I cannot talk much about it. But I know that at least like talking about LangGraph, on my perception, that's opinion-based, my perception is quite dominant in the companies and enterprise as a go-to solution. We have different frameworks for libraries for orchestrate large language models, and LangGraph is highly used. It is not dependent of LangChain. We can use, of course, like quite easy to use both, but it's not dependent. You can use like with any kind of other libraries. About the agentic approach, yeah, I also use LangGraph for orchestrating multi-agent, so you can use it as well. You can use Couto AI if you're like really interested in like, having specialized systems that communicate with each other. But most of my experience with LangGraph. So, yeah. So, okay. Now I'm going to just like walk you through how you can explore the solution I have developed for the university. Basically, it's kind of quite similar from the code base here, but I'm not going to have time to explore in detail. So like just like going like homework if you want to go ahead of it. So basically, I have structured all this package, all this like folder as a Python package. Also use UV, like UV and PyProject TML. That's quite powerful to control the application, command line interfaces and so on. Also linting, formatting, doc styles, and everything. So I have all the project configuration has a common file, and that's the file in the pyproject.tl.ml. So that's the entry point of the configuration. And then I have the folder NL2SQL that's have the source code of the file. So I have some configurations here and the database. So basically, for the database, I have provided a way to connect to multiple databases. In my case, I'm only using Postgres. So I have been using like PyData, and I created like a base model with like abstract class. So anyone can add a new database if you want to, as long as you follow these common patterns here. So you really need to have a create URE file and also a create engine. So that's all. The way you do it, it doesn't matter as long as we have these functions here. Then the rest of the code, the whole package is going to work as usual. And then if you want to get started, you can see the implementation for PostgreSQL connector over here. And then I have a configs file as well. So it's all documented in the README, but I'm going to talk here. If you have any question, please raise your hands about it. So I have also a configs file. So it specifies, for example, the database. If you want to, it's not required to use this file here, but I can like provide passwords and so on. Actually, it's not good to have password hard-coded in the config file. So actually, if I don't use it, it's going to work as well, because in my implementation, I'm going to try to get it from either environment variable or the PG pass, and that's specifically for Postgres in this case. So like it try to read from the user folder the .pg pass file. But this one here is important. It's the prompt and the schema one. So prompts, just to like centralize all prompts that I'm using in the LangGraph flow for that approach that I showed you. So, for example, I have like an intent classifier. If you see that the LangGraph code is the first node that classifies the user questions about like small talk or related to the SQL database. So, and then I also have like a chat agent. So if it's not, I have a two agent, like the chat agent and the SQL agent. So if it's small talk, it goes to the chat agent and can either answer politely or use tools for explaining like in details. Like that's kind of like a didactic, like a teacher for SQL for like domain scientists and non-technical people. Then have the SQL generator prompt. So that's the code that is asking for generating the code. So I have I also provide some key rules. Since I'm also using the history, it also takes in consideration the chat history. So it takes in consideration the schema context. Like I told you, in this case, I'm I'm placing from everything for the target tables and files and columns that I have. The SQL examples, this is coming from a RAG approach. So it's based on similarity. So it's always changing depending on the question. He's like fixed. He is like changing at the time. And then have the chat history. So let's say the user asks, how many calls do you have in the state of Mato Grosso do Sul? And what about Rio de Janeiro? So like they understand context this way. And that's for the tool, the query explainer. We have for the query fixer as well, and the analyzer, and the saved validator here as well. And here I'm passing all the tables that I want to use. So other than that, I have the specific files for knowledge base. So Also use the PyData just to retrieve information about the columns, tables, and so on, to retrieve information about examples, and to create for the first time the vector store and populate the vector store as needed. So basically, it runs once, like I just set up, like create the vector store, it creates, and then we can just forget this step and just like focus on the chat. And our implementation is under the agents folder. Have the API just for the fast API. That's usually the way it works for this kind of application. Just always an API and endpoint that's going to be connected to the front end of application. And then have the graphs here. Okay, you can explore it later, but one thing that's going to be easier to explore is through notebooks. So notebooks not good for production, just like exploring. And so I try to make step by step before moving it out to this modularized code. So always that you see 0.0 is just like the first implementation with any kind of modularization at all. Then starting at 0.1 or like a number n.1 onwards, then I started I'm using the modularized code already. So just when you see like without modularization and with modularization. So basically to show how to connect to the database, to show how to create the dictionary like without modularization using like best practices. To work with the load examples, vector store. The most importantly, I feel like most interesting for you guys, it's starting the 4.0 and 4.1. And that's where you have the implementation of the LangGraph directly. So I start with only the logic here, with all the nodes and all the how to implement the graph directly. So, for example, here we have this graph. It's a really huge graph, but with no implementations at all. Then in the next notebook, I start implementing it. Well, like I say, I don't have too much eyes. It will be like 4 hours for the SciPy for run walking through this code. But like at least in my conception, like a production grade code so you can like leverage as much as possible for your own use case. Yeah, there's like another tip, like usually it's good to work with source code. So the source code, like anything that, for example, in this case, an L2SQL folder, we implement all the logic and so on. But then you can, the logic for the chat, the logic for like building the whole pipeline, automating everything, usually it's separated. So you can have like a folder like scripts that calls all the core function, like a command line interface, or just like the API like directly. So, and I think that's it from my side. So I'd like to have more time to show how the LangGraph work, but like I was just 10 minutes, so I'd rather recommend checking the notebook starting from 4 dot something.
So anyone have a questions? Okay.
I have a two-part question. I'm curious if you've tried to run any evals over the outputs of the SQL that's generated, and have you like got any sense of how promptable or how tractable it is to like the problems of writing longer and more complicated SQL queries? Because I've been working on something similar at my company, and like the easy queries are easy, of course, but then like the long queries and the ones that are like computationally expensive or query time expensive are the ones that are the hardest to optimize. And I'm just curious if you have any reflections on that.
Yeah, that's a really good question. So I have some tips that worked well for me. And also, in this case, not in this repository, but it's really good to have implemented evaluator way, right, to evaluate it. At first, we try to evaluate manually, so we have rounds of coding together, we have establish some pair of questions, create an Excel sheet, and then try to see if it's correct or not, provide some metrics of it. But it's not scalable, right? Because if you change anything, then we need to manually check it again. So, but one good way to evaluate it is just providing the expected results in this case, not the query itself, because the query can be changed, like any space and things, it's hard to track, but just the final results. That's, I think that's needed, and that's good to scale a bit, to evaluate it at scale. But talking about complex queries, so based on my experience, I also I start the first implementations, it work well for simple queries, then queries with 3, 4 joins, a lot of conditions, and procedure as well. I have possibly procedures that you need to use. It was harder, but something that helped a lot is, from our case, is examples. So examples kind of almost solved most of the problem, almost 100%. Still have some issues here and there, but it solved a lot.
Well, thank you for very insightful and detailed toolbox. Manuals testing, specifically how you compared several actually frameworks to implement that SQL interactions with agents. So my question is, did you consider some ways to combat hallucinations in specifically ML agents working with SQL? I assume that for business implementation, it's quite important. So for business to establish trust is to make it as much as possible hallucination-free. Yeah, unfortunately, I think that it will be problematic for them to rely on these insights obtained this way.
Yeah. That's a concern for sure. So I would say I have 3 main ways to do it. Prompt engineering, that's easiest, but it helps. Good prompt engineering, like I said, examples. I saw a strong boost in the performance of providing examples for complex queries, and also human in the loop, right? I still have a human in the loop, so I still relying on engineers. Reduce a lot of the time of the data engineers, but at least right now they're still before providing an answer that's going to go to the scientific papers, the engineers review it.
Yeah. So thank you for the talk. I really loved it. I think my question's on non-determinism and slightly more complicated queries. So I was playing with the questions and trying to get the query to join a bunch of tables. And the first time it didn't work. And then I changed the query to just give it a bit more context because I'm looking at the tables. And then it worked. And then I went back to the old query. And now the query that didn't work with the prompt before started working again. So how would you handle this? Is this a bug, or how would you take care of this?
I think that's the main issue when using large language models, so you should use carefully. But that's why again, just kind of repeating the answer about I'm going to provide some examples about prompt engineering. So this approach, this easiest approach, we spent a few minutes implementing it. So I wouldn't expect it to work good for complex query at all. We didn't provide examples. We didn't provide good prompt engineering. Sometimes we don't even have control on the system prompt used. So that's why in my lab I have customized everything, provided very careful, detailed prompts. Large language model is still going to be under. We didn't control temperature here, anything. So it's expected to be bad. Once we apply all the best practices, it's still not sure that we're going to have reliable good results, but it's way more reliable. So.
Thanks. Also, thanks for the insightful presentation. Was wondering is how do you make sure that you apply the correct filters when humans, for example, have typos in the natural language question or use some abbreviations? And so do you have some tools or functions to check the distinct occurrences, for example, of the categorical features in the database?
Yeah, that's a good question. So I have implemented like a fixer for it. So let me see here. I have like 2 nodes in the original graph. So one of them is like SQL saved validation. This case just like checking for unsafe words. But in your case, like a kind of syntax validator. So fortunately, Postgres has a function that validates the syntax directly. So it's called, let me see what is the function coming from. Yeah, it's called like prepare, like validate as TMT and so on. So it also provides, so it checks the syntax and also provides some information about the error if it has any kind of syntax. And then using a large language model in this node, in case you have like it didn't pass the syntax for any reason, then you're going to try to get the code, the issue, and now ask a large language model to regenerate the question, the answer, based on this output. So we tried up to 3 times. At least from production, we didn't face any 3 times issue, because once it reached the 3rd time, it doesn't work. So like we provide an answer to the user. Okay, so that's the try 2 times and it's not working. But it hasn't happened to us, so I believe it's working good. Any further questions?
Okay, so thanks for joining this long session again, and also another big applause for a speaker. And yeah.